Good afternoon, viewers. Welcome back to Easy Mathematics. Today, we were supposed to look at construction, but we were told by one of our subscribers, our follower, to talk about Venn diagram or two-set problem, which is the progression towards BEC. So today, we want to look at two-set problem. And when we say two-set problem, it simply means how to handle problems in a Venn diagram way or style. So when it comes to the set problem, let's say maybe we have a universal set U. So let's say we have a universal set U, and we have other sets as set A and set B. Now with the Venn diagram, this set A and set B are subsets of the universal set. So when it comes to the universal set, it simply means the total number of sets what we are having. Then the set A and the set B are subset, which means we can find or we can get them in the universal set. So let's say we have the diagram as this, which is the Venn diagram. With the Venn diagram, this set A, let's assume, takes the first circle here, and we can give the set B to the second circle. Then the universal set is all the sets in this rectangle put together. So we say the set A and the set B are subsets of the universal set. So this set A is positioned here as, let's say, the number of set A members. Then we have the B as here, we say the number of set B. Then the universal set is positioned here and say the number of U, which is the universal set. So this set and this set, since they are joined, it means they have something in common, and we call it the intersection of these two sets. And more of this were explained when we were introduced sets in Form 1. We have the disjoint set, intersection, we have complement set, and we have universal set, and also how to list and describe sets. But we are looking at how to handle or solve two-set problem. And to solve a two-set problem, what we have to know is that when it comes to the Venn diagram like this, the set here and this set, they join, which means they have something in common, which is the intersection. Then we have the universal set. This universal set is the total or the sum of all the elements in the set. So set A and set B are subsets of the universal set, which means when we add all this together, giving out the universal set, we have the element of A inside and that of B inside. So when it comes to Venn diagram, in terms of solving two-set problem, the set here has been divided into 4 regions. We have the first region as region I, which is located here. And we have the second region as region II. And the third region as region III. Then the region IV here is also another region. So when you add all these regions together, it gives you the universal set in terms of two-set problem. So this region plus this region plus this region plus this region put together gives you the universal set. And if we want to define the set here, which is the region I, the region I is classified or is defined as the number here, this set here only. So we say the number of A only. When we say only, it means the B is not included. The portion here, if I circle this, you will notice that the B portion is inside the A portion. And if I circle this one too, it means the B portion is also inside the A portion. So the I region is A only, the B is not included. Then we have the region II, which is the intersection of A and B. The element that can be found in A at the same time in B. So I have this as the number of A intersection B. And this was made more use when we were introduced in sets in Form 1, based on the old curriculum or the old syllabus. So this region is A only, which means it belongs to only this set, and the B is excluded. Then we have the region III as B only, the number B only, which means also that this portion is excluded. So the B only is this region, and the A only is also this region, and this region is the intersection. Then we have the fourth region, which is the number of A union B prime, which is also known as complement. When we say complement, they are in the universal set but do not belong to any of the two sets here. So the complements do not belong to A, neither does it belong to B, but it can be found in the universal set. That's why we said that the sum of all the sets in this rectangle gives you the universal set. So with the complement, which is the region IV, it is in the universal set. You can find this in the universal set, but cannot locate it in the set A and set B. So since they do not belong to set A, they do not belong to set B, they are classified as complements, and it is being represented by this. So on the Venn diagram, in terms of equation, we say that the region I here plus the region II plus the region III plus IV gives you the universal set. So we say the number of U, which is the universal set, is equal to the region I plus region II plus region III plus the region IV. So if you put all these four regions together, it is equivalent to the universal set. Note that we've defined the I as A only. When we say only, it means the B is excluded. But if I say A, the set A, it could be possible that all the sets or the elements in set A, some are also in set B. So with the A only, it means it belongs to A and B is excluded. Then the region II, it is both A and B, which is the element that is in A and at the same time it is also in B. Then we have the region III, which is B only. Also A is excluded. Then we have IV. So with this, we can solve for the problem in two-set problems. In terms of writing their elements or representing them by their elements, we can say the number U is equal to the number A, which is the whole of this, plus the number B, which is also the whole of this, then minus the number A intersection B. But most of the times, we use this equation. Most of the times, we use this plus this plus this plus this. So if you want to use this approach, you can. But let us use and understand this approach to be able to identify the only and the complement and the rest. So let's take the first example. We have, in a class of 40 students, 30 read mathematics and 20 read English. Each student read at least one subject. Illustrate this information on a Venn diagram. How many students read both subjects? So anytime you have to answer a question on Venn diagram, we have to first list our data based on what we are coming to work with. Now when you come here, you notice that we have region this, this, and this. So to answer this question as a Venn diagram, we are going to first list our set of data. Because on the Venn diagram, we are not going to write mathematics here, we are not going to write English here in terms of their full spelling, but we'll shorten it with their first letter. So to be able to answer a question like this, first write a data and ask yourself, what are the two subjects have they mentioned there? They've mentioned mathematics and English. And when we started, they said in a class of, which means the total number of students in the class are what? 40 from the question. So in terms of universal set, it is 40. So we are going to draw or write a data and say, let the number U be equal to the universal set. Then you ask yourself, what is the universal set from the question? The question said in a class of 40. So the total universal set, the universal set is 40. So let the number U be equal to 40. Then what are the two things they've mentioned in the question? They've mentioned mathematics and English. So we are going to say, let the number M be equal to mathematics. Then the number E should be equal to English. So come back to the question. in a class of 40 students, so the total number of students is 40, which is the universal set. 30 read mathematics. So the number of students that read mathematics are 30. And we've written here that let the number n, which is mathematics, be equal to this. And from the question, it is 30. Then when you continue, it says that 20 read English. So we are going to write it here as English. 20 of them read English. Now, if some read mathematics and other read English, it is possible that some of the students read both English and at the same time, they also read mathematics. So we are going to say, let the number n intersection E be intersection or both subjects. So this represents the students that read mathematics at the same time they read English. But from the question we have not been given. We have been given that of mathematics and that of English. So we are going to represent the number of students that read both mathematics and English. We'll represent it with a variable. Let's say x. Then we will come and draw the Venn diagram which has been asked for us to draw. So we have to illustrate the information on a Venn diagram. And with a Venn diagram, we need a rectangle and our balls this way. If we are coming to draw the Venn diagram based on this data, from the explanation here, we have been told that the universal set is always at the top right corner here. So the universal set that we've written here, we are going to choose the abbreviations. We will say the number u is equal to 40 because we have the data here, which was from the question. Then the number of m and the number of e, we will distribute them to the circles. So we will give this to the number of m and give this to the number of English. So this is equal to, from the question, it is 30. Then that of English is 20. Now, when we were explaining back then, we said this region is A only. And this region is both A and B. The same thing happens to this one, that the region here is M only. And the region here is for M and also for E. From the question or from our data, we don't know, so we represented it with a variable. So the number of M intersection E, representing it with a variable here, we drop it down here. Now when you look at the question carefully, you don't have a complement, which means all the students did maths, some did science, English, sorry. How will you know that in a question there is no complement? If you see in a question, at least each of them studied one subject, it means there is no complement. So it means this region is 0. So in writing that one, we are just going to write plus 0, or we ignore it or not write it at all. So this region plus this region plus this is the same as what? The universal set. If there is no complement. Good. So since there are no complement, or each of the students did at least one of the subjects, then we are going to have our set of diagram in this way. Now, this region, which is the region I, is the number of mathematics only, and this region is number of English only. Since this value here wasn't stated in the question, that it is mathematics only, we are going to drop this 30 in the only section. Then we will subtract this portion out. Why are we subtracting? Because this portion has chopped into the only. So we will take that portion off to get the M only. So now M only is 30 minus X. Also, when you come to the 20 for English, the question did not state that 20 read English only. That is why we wrote it at the top here. So to get the English only, we are also going to drop the 20 in the only section, then we subtract the X from it, because the X here has chopped into the portion of the 20. And now we have this as our Venn diagram. So we have illustrated this information on the diagram like this. When you continue, you have to calculate the students who read both subjects. Those who read both subjects are what we indicated here as x. So therefore, solve for x. Using what we said that region I, which is the only, plus the region II, which is the both subject, plus the region III, which is the only English, is equal to the universal set. Since there is no complement, this region plus this is equivalent to the universal set. So what do? We are going to say the number u is equal to region I plus region II plus region III plus region IV. But the region IV is 0, so there's no need for us to write the region IV. So now, what is the universal set from the question? It's 40. So let's write it down here. 40 is equal to region I, which is M only. What do we have there? We have 30 minus x plus region II. What do we have at region II? We have x plus region III. We have 20 minus x. Then we solve this equation by grouping of like terms. So let's group the like terms here. But you notice that there's a negative x here and there's a positive x here. So this negative x will cancel the positive x. Now we have 40 is equal to 30 plus 20, giving you 50 minus x. Then you group like term for x to stand alone. So if I want to move the x to this side, the negative here will change to positive x is equal to 50. Then the 40 will cross, giving me negative 40. Then you subtract. X is equal to 10. Now from our data, we said let x represent both subjects. And you were asked to calculate both subjects. So we are going to say, therefore, 10 students study both subjects. Then you solve the II for that. When you finish, you will redraw the Venn diagram because there is no space. We can't draw. We will redraw the Venn diagram. Position the x here, which is 10, 10, and 10. So if you subtract 10 from 30, you have 20. If you subtract 10 from 20, you have 10. So it means the only for mathematics is 20. The x is 10, and this is 10. So you will see that when you add the only plus the both plus the only here is equivalent to what? 40. And this is how we solve a question on Venn diagram without a complement. Let's take the number 2. Let's read it carefully. It is similar to the first one. In a class of 60 students, so once they mention or they inform that in a class of 60 students, it means the universal set is what? 60. 46 pass P and 42 pass Arabic. Each student pass at least one of the two subjects. Now since we've said at least, it means there is no complement, which means all the students, if the person didn't perform P or they didn't perform well in P, he or she performed well in Arabic. So there is no complement. Now we have here, illustrate the information on the Venn diagram. Then how many students pass in both subjects? So to draw or illustrate the information on the Venn diagram, I will first need my data. So with the data, I am going to define the set of words and the numbers I'm going to use on my diagram. So I'm going to say, let the number u be equal to universal set, which is equal to. Then when you look at the question, they've mentioned two problems. That's why we said two set problems. This is one set, this is the other set. So they've mentioned two subjects, P and Arabic. So the first letter for P is T. So the number T should be equal to P, which is equal to. Then the number A from the question, which is equal to Arabic. When you read, it says that in a class of 60, so they've mentioned the universal set as 60. And they said that 46 pass P. It did not say only, it said P. 46 pass P. So 46 of them pass P. And 42 pass Arabic. So 42 pass Arabic. Now with this one, since they've not mentioned only for you, definitely there are some of the students that pass in G at the same time they pass in Arabic. So we call them intersection. And even from the question, we have to calculate for both subjects, which is the intersection. So I am going to say, let the number T intersection A, which is both subjects, be equal to, I wasn't given, so let's say 1. With any variable, you can choose A, you can choose B. So let's say 1. Now with the intersection here, we were taught from the introduction of sets in Form 1. So I hope this is not something new for us. So with this data, we can draw our what? Venn diagram. So the person said, illustrate this information on a Venn diagram. So this information is what we've defined it as this. So I have my diagram like this. Let me draw it. So we have this, the first one, second one. We have here as our universal set. Then looking at what we are dealing with, Chi and Arabic. So this will be the number of Chi. This is the number of Arabic. Then with this one, we have 46. It is not only, it is 46. So we are going to write the 46 here. Then the Arabic 2 is 42. So we are going to write it here. Then we have both subjects, which is the intersection of Chi and Arabic as Y, because we have made it Y by saying let the number of T intersection A be Y. Now from here, since the 46 up there, they are the students that did Chi, and the Chi portion is the whole of this circle. So since Y is in the 46, we have to subtract the Y from the 46 to get this region only. So we are going to say 46 minus Y. The same thing here, this 42 belongs to the whole circle here. Since we want this region only, we will bring the 42 in, then we subtract the Y, so that we'll be able to get only the A only there. And also, from the question, it was stated at least they did one of the two subjects, which means there is no complement. They all did one. So now that I have this, I can now calculate for II, which says how many students pass in both subjects. So in both subjects, to calculate for the Y, we are going to add the region I plus region II plus region III and equate it to the universal set. What is the universal set? From the question and our data is 60. So we are going to say the number of U, which is the universal set, is equal to region I plus region II plus region III. What do we have in the universal set? We have 60. So 60 is equal to region I. What do we have there? We have 46 minus Y plus region 2. We have Y plus region 3. We have 42 minus Y. So we can say that negative and this positive will cancel out, because 1 minus 1 is 0. So this will cancel out this. Now we are having 60 is equal to 46 plus 42, which is going to give us 88 minus Y. Then from here we group like things. If we lift the Y to this side, the positive negative here, the sign negative here will change to positive Y, which is equal to 88 minus 60. So now that I have 88 minus 60, if you subtract 60 from 88, you have 28 left. So Y is equal to 28. And this 28, which is the Y, we stated here that let the number of T intersection A, which is both subjects, be Y. So now we can say clearly that, therefore, 28 students passed both subjects. And that's the answer for the number II. Then with the III, we have to what? Calculate or know the number of students who pass in only Arabic. This is the Chi, and this is the only. This is the Arabic, and this is the only. This portion is the only. And what do we have there? We have 42 minus Y. this region, which is the third region, is the only for the Arabic. So if we are to calculate only Arabic, then it means we are going to subtract the y from 42. And what did we get for y? We had 48. So we are going to say 28 minus this. So 42 minus 28. So if you have 42 and you take away 28, that is going to give you 14. 42 minus 28 will give you 14. So this is going to give you 14. So the question, how many students passed in only Arabic? Only Arabic are 14. But with the 42 which was mentioned here, they are the students that did Arabic in all. But those who did only Arabic and did not include Chi are 14. So we state our answer and say, therefore, 14 students passed in only Arabic. Because there is difference between Arabic and only Arabic, or Arabic only. Okay, so now we know that there is a difference between Arabic and Arabic only, or only and the other one. Let's look at the question with the only. In a school of 225 students, 80 of them study Arabic only, and 125 study French only. Each student studies at least. So now we've seen at least, it means there is no region 4 or IV. Now what am I to do? I'm to draw a Venn diagram for the information. So I need a data which will define what has been written here to be able to draw my Venn diagram. So I'm going to say, let the number U be universal set. What have they mentioned? They mentioned Arabic and French. So the number A is Arabic and the number F is French. Then automatically I have to get my A intersection F, which is both subjects. Now let's get back to the question. In a school of 225 students, so in a school, which means the universal set there has been given as 225. 80 of them study Arabic only, not Arabic. With the only, it means they concentrated only on Arabic without French. So that 80 here do not belong to the Arabic here. This is Arabic. So we are going to write it Arabic only as the number A only, which is equal to 80. Then when you continue, 125 study French only. They did not study French, but French only. So also we are going to say the number F only from the question 125. Then the number of students that study both French and Arabic, we don't know. So we represent it with a variable, say A. Then we draw the Venn diagram for this set of data to illustrate the information. So let's take a break and see how the drawing is going to be. Okay, so now we have space to look at it. So now we have, from the other end there, we have the universal set as 225. But the number of Arabic was not given. The number of French was not given. So we will leave that one, or also represent it with a variable. So let me represent it, or you leave it there like that. Then you have the number of A intersection F, which is both subjects. And that one, we have represented it as the variable A. But the one we were given from the question is Arabic only as 80, and the number of French only as 125. So on the Venn diagram, this is how we are going to illustrate the information. First, we need our diagram this way. We know that the universal set is located here. From the question, there are 225 students. Then the things they are talking about are Arabic, the subjects are Arabic and French. So this takes the number of A and the number of F. Since we were not given the value here, we are not going to write anything here. But we were given Arabic only, which is the region I. So we will record it here without subtracting the A that we've represented for the both. Why are we not subtracting? Because this given number is only. So we don't need it. Good. Then when you continue, he said 125 study French only. Also, because it is only, we will write 125 here without subtracting the A. If, let's say, in the question they mentioned or they said 125 study French, with that one, we will write the 125 here, bring it inside, and subtract the intersection. But because this is only, there is no need to subtract. So they only go straight to their portion, and the values themselves goes up here. So this is how the Venn diagram is going to be for this question. Now when you continue, I have illustrated the I. It says that how many students study both subjects? So this is I. Then we have here I. How many students study both subjects? From my data, I said let the number A intersection F, this one, be equal to both subjects, which is the A I have there as my variable. So on the diagram here, this is A. And how do we solve for the both subjects? We know very well that the number of universal sets is equal to the region I plus the region II plus the region III plus the IV gives you the universal set. But since they mentioned at least no universal set. Good. What do we have for the universal set? 225. So we have here 225, which is equal to region I only 80, region II A plus region III 125. So when you group like terms, you are going to get 225 is equal to 80 plus 125 plus A. You are going to get 225 is equal to 80 plus 125 will give you 205 plus A. Because this plus this is 5. This plus this is 10. So 0. Remember 1, giving you 2. Then you group like terms. 225 minus 205 is equal to A. This will cross. And if you subtract, you are going to get 20 is equal to A. Or A is equal to 20. Now this A, we said let it be the both subjects. So we'll state and say, therefore, 20 students study or pass both subjects. Now when you continue, you have been asked to calculate French. The French is the whole circle for the portion French. So when you come to the diagram here, the portion for French is this. This is the French. So the region here plus this region will give you the French. So with the II beta, you have region I. So to calculate the number of French, it is region I plus region II. What do we have for region I? A. What is A? 20 plus region II 125. So this is equal to 145. So those who studied French are 145 students. And this is how we solve questions without complements. If God permits, next week when we meet, we'll take more examples on the Venn diagram without complements, so that we'll get the understanding more on it. See you God willing next week as we explain more. Because of our time, we'll shorten it for now. Bye bye.